All right, Daniel here, and we're back to the file system application. And in this video, I'm going to implement a very simple command, the pwd, which prints the current working directory. And also, we are going to implement creating empty files. And that, my friends, is going to involve some refactoring, which is a skill that I encourage you to improve as you're writing Scala code, and this will be a perfect opportunity for you to do that. So without further ado, given our two main goals for this video, I'm going to right click on the commands package and create the pwd command. So right click new Scala class, and I'm going to create this pwd. Cool. The pwd command is going to extend command, right? And the compiler says pwd needs to override apply with a state, which is a state, and Alt Enter to import this for me, and it returns a state. And pwd does nothing else than setting a message to the current state. So state.setMessage, and this will print out the working directory's path. So state.wd.path. And that will be all. This is going to be the whole implementation of pwd due to our design as an object-oriented class extension. Next, we're going to support it in the command from factory method. So we're going to say else if pwd equals token 0. We're going to return a new pwd, otherwise new unknown command. And this pwd constant, we're going to declare it right above. So val pwd is going to be the string pwd. And that is it. We now support a new command. Cool, so let's rerun this application. And if I say pwd, look, I have the slash, which is the absolute path that I'm currently working on. As we implement more commands, such as the change directory command, this pwd will prove more powerful as we go along. But now, pwd, we assume that it works well. Now, goal number 1 is checked. Goal number 2 is creating files. This is a little bit more involved. But creating files, as we discussed earlier, is going to mimic mkdir. So the logic in mkdir is going to be mostly the same for creating files as well. The only difference here is that we're creating a file, not a folder, but the logic of updating directory structures and returning new roots and new working directories and so on and so forth is going to stay the same. So we are going to do a little bit of refactoring here, but that will come after we create the file directory entry here. So let's go ahead and right click on files and creating the file directory entry. So files will extend the dir entry here. So files will contain a parent path and a name and some contents. So override val parent path, which is a string, override val name, which is a string, and some contents, which we are going to consider it to be a string. So all the files are text files. You can extend files after we finish this application. You can create some extra file types if you wish. And this guy will extend the dir entry. Notice that I've already written the override keyword here because I know that I'm going to extend the dir entry with parent path and name. So parent path and name. Okay. Now, I need to override some methods here. So let's see what we need to override. These guys. Path is already written, as directory, and get type. Cool. So I'm going to copy these and paste them into file. So as directory, a file as directory will throw an exception because a file cannot be converted to a directory. So we're going to throw new. We should probably create our own exception at this point, but just let's call this file system exception. And we're going to paste a message here which says file cannot be converted to a directory. And we're going to create this little class in the file system package, but let's finish with the methods here. So get type here is going to return file in much the same way as get type for directories, just returns the string directory. And now in the file system package, we're going to create this little file system exception class. So in the file system, I'm going to create the new Scala class. I'm going to call this file system exception. And this guy will receive a message as a parameter to its constructor. So message is going to be a string, right? And this will extend the very popular Java runtime exception with message. Runtime exceptions are thrown by the JVM as the program runs. In Java, there are some special types of exceptions that are called checked exceptions that the compiler forces you to catch when you write code. But in Scala, every exception is a runtime exception, so there are no such things as checked exceptions. That is, the compiler for Scala will not force you to catch exceptions as you write code. So file system exception extends runtime exception, and that it's probably going to be all. This file system exception is going to be just a good name for us to keep track of. And if we wanted to add some additional functionality, we can add additional methods in the file system exception. So it's good to have this as a separate class. Okay, back to files. So we have file system exceptions. We need to import it. Okay. We have as directory, but it's not really fair. We also need as files, a very similar method to convert a directory entry to a file as well. So let's go to dir entry and say def as file, which converts a dir entry to a file. And let's implement this in directory and in file as well. So def is file as file, which returns a file. And obviously this is not going to work because directories cannot be converted to files. So we're going to throw an exception as well. So throw new file system exception, and we're going to say a directory cannot be converted to a file. Okay, and in file we're going to implement the def as file, which returns a file and just returns this exact instance. Okay, so cool, we kept the pattern. Next, we should probably create a file companion object in much the same way as we did for folders. So I'm going to create a companion object here. And I'm probably going to hold some constants, and I'm going to create a small utility method in much the same way as we did for directories. So if you remember, we have this def empty here in the directory companion object. We're going to do the same for files. So I'm going to create a def empty method in which I'm going to pass in a parent path, which is a string, and the name of the file, which is also going to be a string. And this returns a file. And here I'm going to actually construct a file instance. So I'm going to say new file with parent path, name, and empty content, so nothing in the file. Cool, so we have files. Good. Now, how do we create them? Well, we need to support a touch command. If you remember, touch is going to create empty files. Now, as I said before, touch is going to mimic many of the things that we did for creating directories. So if we go on and read on this code, mkdir does most of the things we already need for files as well. So for example, if the working directory already has an entry with the name that we want to create, if the name already the entry name contains the directory separator, if the name of the entry is illegal, otherwise do mkdir, or in our case, do create file or something. The check illegal is going to be mostly the same, and the create entry here, in our case, the update structure is going to stay pretty much identical. We don't really need, we're not really differentiating directories versus files, right? Because this new entry, as you remember, was a dir entry. So this will work just as well for files and for folders, because we've put a little thought beforehand into designing this function. So update structure is going to work exactly the same. The logic here is going to be mostly the same. So obtaining the current working directory, obtaining all the directories in the current path. This guy is going to be different. This guy is going to be probably the only different statement that will differentiate mkdir from creating files. Other than that, we obtain the new root and the new working directory, which is exactly the same thing. So update structure works the same as we discussed before, and find descendant doesn't really make the difference between creating a file and creating a folder. So we get to the conclusion that mkdir and touch only differ by this line. One would be tempted to copy this entire code and just replace this line into touch, but that would be a bad coding design decision. So we are going to do a little bit of refactoring to only make the difference in one line between mkdir and touch. To do that, I am going to create a general class for mkdir and touch. I'm going to call this, say, create entry. So I'm going to create a new Scala class in the commands package. I'm going to call this create entry. I think this is a good name. So create entry will receive an entry name, just as we did for mkdir. Entry name is going to be a string. And this guy will extend, actually, we'll extend command, just as mkdir did, okay? But most of these things will probably move to create entry. So bear with me here, because I'm going to copy this entire code in mkdir. I'm going to paste it into create entry. I'm going to enter here such that IntelliJ will import my my types for me. This name here is not found because I named this entry name instead of name. I'm just going to put it name here. So all this logic is going to stay the same. Okay. And as I said, this guy is going to be different. So val new entry is going to be something. This is going to be a dir entry. Okay. So let's just add a to do here. Implement this. And I'm going to pass in new entry here. Okay, so now all the logic for creating an entry, be it a file or a folder, is in this general create empty entry class, and mkdir will extend create entry with name, and it will do its own thing when it creates a new entry. So this guy, this question, is going to be implemented differently for mkdir and touch. That is, I'm going to create an abstract method here, create entry, or do create entry, or something like that. And I'm going to pass in the state, because I don't have access to it unless I'm in the apply method. And I'm going to call create empty, do create entry from the apply method. So I'm going to pass in the state here. And the entry name is going to be a string. And this will return a dir entry. And this will be an abstract method which will need to be implemented in mkdir and in touch. So here I'm going to call it do create entry with state and the entry name that I want to pass in. This is called name. I think I've messed up some method names here. Let's correct them now. So instead of do mkdir in create entry, let's call this one do create entry. And this guy create specific entry. Okay. So this guy will call create specific entry with state and name. And this method will be abstract. We rename this method do create entry, which will need to be updated here. Instead of do mkdir, I'm going to call this method do create entry. Okay, and I'm going to have to declare this class to be abstract, such that the compiler will allow me to create abstract methods. And that, my folks, should be it. And in mkdir, I'm going to need to override this method. So in mkdir, I'm going to override. Okay. And this will be the actual entry creation from the state's working directory. So this will create an empty directory in the state's working directory path. So this will be directory empty from state working directory and path. And the entry name here is going to be the name of directory that I want to create. If you take a second to think about this, this was the exact line that was in this point. So instead of this new entry, we had this same line here, directory empty, state wd path and entry name, in the mkdir implementation. But now we've moved that into a more general class. And this create specific entry will be called in the mkdir class, and it will create a directory for us. Now in the touch command, this create specific entry will have a different implementation, and it will create a file for us instead. But the same logic is going to apply for both files and folders, like we discussed a few minutes ago. So now in the touch command, which I haven't created yet, so go ahead and create a new Scala class in the commands package. I'm going to call this touch. And I'm going to pass in a name, which is a string, extends create entry with name, and I'm going to have to override def create entry, or create specific entry, I think we named it, right? Cool. And in this case, we'll create a new file. So file.empty. Let's Alt-Enter and import the file from the RTJVM package. And we'll pass in file.empty from state wd path, which is the parent path of this file, and the file name that we need. So we pass in the name here. And now that I notice, we have the name both in the constructor parameter for touch and for mkdir as well, and the entry name for the create specific entry method. I think we're being overzealous here, and we need to remove this parameter because they will both have the same value all the time. So create specific entry should only take one parameter, state, because the name of the file or the name of the folder will be contained in the constructor for the classes, so no need to pass that to the method as well. Okay, and in mkdir, I'm going to delete that. And name. Awesome. Cool. Now we need to actually support the touch command in the command factory method. So else if touch equals token 0, then same logic here, right? And otherwise new touch with tokens 1. And we need to define this constant. Val touch equals the touch word. And that should be it. Let's run the application. So if I rerun this and say mkdir some folder and drums rolling touch some file, and it hasn't crashed. And if I hit ls, which lists the contents of the root folder, I see some folder, which is a directory, and some file, which is a file. This is awesome. So touch works as expected, and it's not really too much of a surprise because touch works in very much the same way as mkdir. So we're good. We're good with touch. And before we get on to test the contents of the file, it doesn't really make sense for us to implement the cat command right now until we implement the echo command, which writes into files. So we're going to leave those for later. And now in the next video, we're going to move to cd. I think that this is the next command that makes sense, which allows us to navigate in our folder structure. So I'll see you very shortly.